for this example, okay, you have this diagram here given. You have this diagram here given. Now a load P, that means this value here, a load P, applied to a steel rod. This is a steel rod actually. Okay, steel rod supported as shown, okay, by an aluminium plate. Okay, this is the aluminium plate. It's supported by this aluminium plate here. Okay, into which the 14 mm diameter hole, this is a 14 mm diameter hole, okay, has been drilled. So there is a hole here lah. Knowing that the shearing stress, now given here is shearing stress, a shearing stress. So when you deal with shearing stress, remember the area that is resisting the force or the load have to be parallel, the area have to be parallel to the line of action of the force. Have to be parallel to the line of action of the force. Okay? So knowing that the shearing stress must not exceed 180 megapascal in the steel rod and 70 megapascal in the aluminium plate. So the shearing stress for the aluminium plate here, shearing stress, 70 megapascal, and the shear stress for the rod is 180 megapascal. Find what is the largest load P that can be applied to this rod. So what you have to do is now, you have to imagine when this force is applied, how this whole thing here is going to fail. Now, what is the section that is going to be sheared? Okay, so now, first I have given you this for the steel, that means for this one, for the one that is in green color. Now, if this material here is not as strong as if this steel rod here is not as strong as the aluminium plate, so this thing here will fail, okay, compared to this. So how does it fail? So remember there's a support here. So what happens when I pull this down? And just imagine that this is the weaker material, the steel. That means if this is a weaker material, when I pull this, okay, what happens is this support here will actually cut this through. That means this part here will actually be cut through, okay, by the aluminium. Okay, so when you refer to this is a circular object, So when it is being sheared, the whole internal surface area of this part, that means based on this, the whole internal surface area of this steel rod will be sheared. So how am I going to measure the internal surface area of this? How am I going to measure the internal surface area of this part that's going to be sheared? So first thing is, okay, this is what I have drawn. I have drawn something like that so that you can imagine, okay, what is actually happening to the internal surface area of this circular object. So you will have a layer that is being cut through by this thing here, by this support here. Okay, in order to find this area, so the first thing is we have to know the circumferential length of this circular object. the circumferential length. So circumferential length usually is given as pi d. That means pi times the diameter, the internal diameter of this, that is 14 mm being cut through here. Then multiply by the thickness of the steel rod, that means of this section. Okay, so basically here, internally circular surface, yeah. Remember, you have to imagine that the internal surface area. So the circumferential length multiplied by the thickness of this 10 mm will give you the area that is subjected to shear. Remember, for shear, imagine the force, the area parallel or being in line with the line of action of the force. So that is the area. Pi d is the circumferential length. That means the circumferential length here. Length. Circumferential length, pi d, multiplied by the thickness of this, will give you the whole internal surface area. So by putting in, okay, this, because this is a circular part, you know, it's just a circular part. So this, okay, is the diameter here, multiplied by the thickness. This is pi d, that is circumferential length. Multiplied by the thickness will give you the area. Okay, will give you this area. Okay, so once you know this and you have the shearing stress on the steel rod, the steel, we are looking at steel. So we are taking this value, not this value, or this is for aluminium. So we know that shear stress is equal to force over area. So this force here is actually the load that is applied here, P. Okay, this is the force or the P. Okay, we actually should write it down as this one, change it to F, or this change it to P. It's okay if you know, okay, if you understand. This can be the P, okay, that is the force, okay. So that is what we want to find. So shear stress times area, so this is the area. Shear stress, this is for steel, so we have to refer to steel, that is 180. So we found that based on this, we found that the force or the load is actually 79.17 kilonewton. Okay, so that is based on steel. Now, based on aluminium, you have this. Okay, you have this. This is 40 mm. So that means now this is tougher. This is tougher than the support. Okay, so this is much more tougher. That means stronger. This is stronger than the support here. Now this support here is made up of aluminium. Okay, it's made up of aluminium. So when this one go through, this part here might be cut off. Okay, it might be cut off. So this part is having a diameter, that means here, is being cut through by this whole thing here. This is 40 mm. Here to here is 40 mm. Okay, and the thickness of this is 8 mm. Okay, 8 mm. So if this is a weaker material, so the internal surface area that is being cut, being sheared, okay, will be this. So the area is pi dt. The d here is the diameter, the diameter of the aluminium here, this part here, based on this part. Okay, so it will be removed. Okay, it will be removed. So for d, by the thickness here is 8 mm. So the area, again, we consider pi dt. So d is the diameter here, and t is the thickness of this. So you got this as the area for the aluminium. So again, we apply, but in this time here, we consider this as section 2 lah. Okay, so from here we find out the force also. Okay, so the force is 70.37 kilonewton. Now, based on these two value, the question is asking us find the largest load that can be applied to the rod. So which of this load, okay, we can consider? Which of this load we can consider? So this part here, the aluminium, can only withstand up to this force, this much of force. For the steel can withstand up to this much of force. If I apply this force here for the aluminium, definitely the aluminium will fail. But then if I apply this force here to both, okay, it might not fail. Okay, it might not fail. So therefore, we have to choose this as to be the answer. Because if I apply this value here to this section itself also, it won't fail. Because 70.37 does not reach this 79.17. Okay, so this part not going to fail, this part also not going to fail. Okay, so based on this value. So if I take this value, yes, both will fail already. So our answer should be this. So in order to remain this, okay, to keep this so that it won't fail, it is advisable for us to apply the maximum load, the largest load that can be applied, to this assembly so that it won't fail is this value, not this value. Okay? That's all for this example.